Okay, so 2 is my base, and I have 32. So can I rewrite 32 as a base of 2? So can I multiply so many 2's together to get 32? Yes, we wrote on the board that it takes 5 of them. So 2 to the 6x stays, but I'm going to change 32 to 2 to the 5th power. But notice that 32 already had an exponent on it, so we're going to put x minus 2 there. So you can't make the x minus 2 disappear. It's part of your exponent. So I wrote 2 to the 5th, but then I kind of put that x minus 2 in parentheses. My bases are the same, so now I can write it as 6x equals 5 times x minus 2. I indeed need to distribute the 5. So it becomes 6x equals 5x minus 10. 5 times x is 5x. 5 times negative 2 is negative 10. And now what are we going to do? We're going to subtract the 5x from both sides. And we're left with x equaling negative 10. You guys remember, your exponent can be a negative. It doesn't have to be a positive number. So x can be anything. I don't want you to think that it doesn't have to be negative. Okay? What questions do you have? Okay, so 27 is the larger number, 3 is my base. Can I write 27 in a base of 3? Yep, I sure can. How many 3's does it take to get 27? 3. So we're going to leave this one. We're going to rewrite 27 as 3 to the 3rd power. And because 2x minus 4 was already in the exponent, we need to leave it. We're going to put that in parentheses. So I just rewrote the 27 as 3 to the 3rd. Now, the bases are the same. So now we can set the exponents equal to each other and solve for x. 5x equals 3 times 2x minus 4. 5x equals 6x minus 12. So I did 3 times 2x, that's how I got 6x. I did 3 times negative 4, that's how I got negative 12. And now what am I going to do? I'm going to subtract 6x from both sides. And I get negative x equals negative 12. Can I leave a variable negative?
No.
No. So what do I need to do in order to... We're going to divide each side by negative 1. X equals 12. What questions do you have? Okay. What do you notice about this one? Can you write 27 as a base of 9? 9 squared, 9 is, 9 to the 1st power is 9. 9 squared is 81. Well, that's not going to work. So is there another way that I could write it? 3. So now we're going to have to write both sides. We're going to have to rewrite both sides. So I can rewrite 9 as a 3. 3 what though? To the 2nd. So I'm going to rewrite 9 as 3 to the 2nd. But remember that 3x plus 1 is still part of that exponent. That's probably the biggest thing that I notice when kids do this, is that they forget that other part of the exponent. Okay, how can I rewrite 27 as a base of 3? 3 to the 3rd. So I just rewrote 27 as 3 to the 3rd. Again, there's part of an exponent there, so we need to leave it. Now, Our bases are the same, so now we can set them equal to each other. Please remember that because I know some of you have already started solving this, if you get your answer as a fraction, it's okay. Answers can be fractions. Don't change them to decimals, leave them as fractions. So I'm going to write 2 times 3x plus 1, because that's that exponent right there. And then I'm going to write 3 times 3x minus 1, because that's that exponent. I'm going to distribute, and then I'm going to solve. 2 times 3x is 6x. 2 times 1 is 2. 3 times 3x is 9x. 3 times negative 1 is negative 3. I'm going to move the 6x to the right side because it's smaller than 9. And then I'm left with 2 equaling 3x minus 3. I would add 2 to both sides. I'm going to add 3 to both sides. I get 5 equals 3x. I am going to divide each side by 3. And I get x equaling 5/3. You guys, if you test this, you'll notice that it would be 3 times 5 is 15. 15 divided by 3 is 5. It actually works out if you leave it as a fraction. And you guys can't see that? There we go. What questions do you have?